The morning of December 24, 1925, did not carry the quiet peace usually reserved for Christmas Eve. At exactly 06:47 a.m., inside a cold, borrowed corner of a machine tool factory in Hartford, Connecticut, a mechanical heart began to beat. It started with a cough, a sharp inhalation of cold air and gasoline, followed by a violent, metallic roar that shattered the silence of the factory floor. It wasn't just an engine, it was a revolution. 9 cylinders, arranged in a perfect, stoic circle, turning explosions into a rhythmic hum that would eventually reshape the skies above every ocean on Earth. Friedrich Rentschler stood in the pale, shivering light of the morning, his eyes fixed on the machine. He watched the pistons, parts he had designed with his own hands and refined in the quiet hours of his mind, pull breath into their steel lungs. The engine ran for exactly 11 minutes. It was a brief window of time, yet in those minutes, the future of aviation was rewritten. There were no cheers, no champagne, and no grand speeches. The men just looked at the dials, recorded the raw numbers into their ledgers, and went back to work with stained hands. They called it the Wasp. It was a name suggested by Rentschler's wife, who had listened to the engineers complain about the high-pitched, persistent buzzing noise during the testing phase. By 1929, the Wasp had become too big for its borrowed home. Pratt and Whitney moved to a sprawling 1,100-acre tract in East Hartford, building more than just assembly lines. They built an entire airfield, a proving ground for engines they were learning to build faster, stronger, and more reliable than any human had thought possible. The crisis did not begin in the quiet streets of Connecticut. It began an ocean away, in the ancient, fearful halls of Europe. By 1938, France, a nation that had led the world in aviation just a decade earlier, realized with a growing cold alarm that it had fallen catastrophically behind. German factories, fueled by a dark ambition, were producing Messerschmitts and Junkers at a pace the French industry simply could not match. War wasn't just coming, it was already a ghost at the table. In a state of absolute desperation, the French government reached across the Atlantic and placed a $2 million order for Pratt & Whitney engines before the year closed. Within months, as the shadows over Europe grew longer, that order swelled to a staggering $85 million. It was more business than Friedrich Rentschler had ever handled in his life, but he knew it wasn't a cause for celebration. It was a final warning. Rentschler understood that Europe was preparing for a war that would consume every scrap of steel and every drop of fuel on the planet. And if that fire spread across the Atlantic, America would need engines, not in the hundreds, but in the tens of thousands. Using the massive influx of French money, Pratt & Whitney did something unprecedented. In just 4 short months during the summer of 1939, they carved out a 280,000 square foot expansion to the East Hartford plant. They hired 3,000 new workers almost overnight. Most of these men and women had never even seen the inside of an aircraft factory. They were farmers, clerks, and shopkeepers who suddenly found themselves measuring tolerances in thousandths of an inch and assembling cylinder heads designed to operate at temperatures exceeding 1,850 degrees Fahrenheit. They were learning on the job, unaware that they were building the very heart of the Allied Air Force. By June 1940, the world watched in horror as German forces swept through the Maginot Line and occupied Paris. The French orders stopped arriving, but by then, the momentum was unstoppable. President Franklin Roosevelt had already issued a challenge that sounded like science fiction. America needed 50,000 aircraft per year. The sleeping giant was waking up, and Pratt & Whitney was about to become the heart that kept it flying. On the morning of May 29, 1940, a test pilot named Lyman Bullard climbed into the cockpit of a prototype fighter unlike anything the U.S. Navy had ever imagined. The XF-4U-1 Corsair sat on the tarmac at Bridgeport Municipal Airport, its inverted gull wings angled down like a hawk preparing to strike. Beneath its massive cowling sat a monster, the Pratt Whitney R2800 Double Wasp. 18 cylinders, arranged in 2 rows of 9, 2,800 cubic inches of displacement, 2,000 horsepower. The propeller was so massive, 13 feet, 4 inches across, that the designers had to bend the wings downward to give it ground clearance without making the landing gear impossibly fragile. Bullard advanced the throttle, and the R2800 didn't just run, it roared with a primeval force. The Corsair lifted off the Connecticut soil and climbed into the sky, and 3 months later, it became the first single-engine American fighter to exceed 400 miles per hour in level flight. The Navy was stunned. But there was a catch. The R2800 was so complex that building it required a level of precision the world had never seen in mass production. The R2800 Double Wasp was more than an engine. It was a challenge to the limits of human manufacturing. It wasn't just powerful, it was impossibly complex. To build a machine that could generate 2,000 horsepower while hurtling through freezing altitudes required a level of precision that felt more like religion than industry. In the East Hartford plant, close enough was a sentence for death. The tolerances were measured in 10,000ths of an inch, a distance so small it is invisible to the naked eye, a fraction of a human hair. The 2 halves of the massive crankcase had to be machined with such absolute perfection that when bolted together, they formed a liquid-tight seal without the use of a single gasket. It was metal on metal, joined so flawlessly that even under the immense pressure of 18 thrashing pistons, not a drop of oil could escape. There is a story, perhaps apocryphal but telling, of a high-ranking German engineer who captured and dismantled an R2800 later in the war. After examining the mirror finish of the bearing surfaces and the microscopic precision of the valve seats, he reportedly turned to his colleagues and said, "If this is what the Americans can mass produce, then the war is already lost." He understood what the world was beginning to learn, that American might wasn't just in the numbers, it was in the terrifying consistency of its quality. By December 1941, as the smoke rose over Pearl Harbor, Pratt and Whitney had 15,000 workers. Within 18 months, that number would triple, but the precision never wavered. They were turning farmers into master machinists who treated a 10,000th of an inch as a sacred boundary. By 1943, East Hartford had become a furnace of humanity. The population of the town tripled. Housing couldn't keep up with the flood of 40,000 men and women who arrived from everywhere. Farm towns in Vermont, mill cities in Massachusetts, and small households where women had never before been permitted to work outside the home. They lived in boarding houses where beds never went cold, rented in hot bed shifts where one worker would climb in just as another climbed out to head for the factory. Inside the plant, the air was a thick, metallic haze of cutting oil and hot steel. Machines ran 24 hours a day, 7 days a week. The casting furnaces glowed like small suns through the night, never allowed to cool, because the war didn't have time for a restart. These workers were driven by a terrifying clarity of purpose. They knew their brothers, sons, and husbands were fighting in the flak-filled skies over Europe or the shark-infested waters of the Pacific. Women made up a massive portion of this workforce, shattering the myth that factory work was too dangerous or technical for them. They operated massive lathes, assembled complex cylinder heads, and used micrometers with a delicacy and precision that often surpassed their male counterparts. Historical photos from 1942 show 3 women inspecting tappet rollers. Their faces are not those of people posing for a propaganda poster. They are focused, serious, and stone-cold determined. They knew that if they missed a single defect, an engine might fail 10,000 miles away, and a pilot, someone's son, would not come home. To understand the R-2800 is to understand the physics of extreme violence contained within a cage of steel. At the center of this 18-cylinder storm was the crankshaft, a single, massive billet of forged steel machined to tolerances that seemed impossible a decade earlier. It weighed over 200 pounds, and it was the spine of the entire machine. Attached to this spine were 18 connecting rods, each driving a piston that ignited fuel and air in a controlled explosion of 1850 degrees Fahrenheit. The crankshaft had to endure rotational forces that would shatter lesser metals like glass. It spun at 2,700 revolutions per minute. At full combat power, the force acting on that single piece of steel exceeded 40 tons, the weight of 10 elephants pressing down on a single point, thousands of times per minute. Then there was the heat. The R-2800 was air-cooled, meaning it relied on the rush of wind over finely machined cooling fins to keep from melting into a puddle of aluminum. These fins were a marvel of manufacturing. If they were machined too thick, the engine would overheat and seize. Too thin, and they would crack under the thermal stress of combat. Engineers and machinists worked in a delicate dance of thousandths of an inch to ensure that heat dissipated at the exact rate required for survival. Every Corsair, every Hellcat, every Thunderbolt that roared into the sky carried this mechanical masterpiece, built by people who knew that speed without precision was nothing more than a fast way to die. In the deafening roar of the East Hartford plant, precision became more than a metric. It became a religion. There was an unspoken covenant between the machinist at her lathe and the pilot over the Solomon Islands. Everyone understood the stakes. A single defective valve spring or a microscopic flaw in a piston ring wasn't just a manufacturing error. It was a death sentence written in steel. An engine failure over the vast, unforgiving Pacific meant a pilot vanished forever into the blue. Because of this, inspectors checked every part multiple times. They measured, they tested, and then they measured again. If a component was even a hair's breadth out of tolerance, it was scrapped without hesitation. There was no room for acceptable losses when the cost was measured in human lives. Occasionally, the war would talk back to the factory. Letters from the front lines, often stained with grease or salt, were forwarded through military channels and pinned to the bulletin boards. A pilot would write to thank the nameless workers for an engine that kept screaming even after taking flak over Rabaul. A mechanic on a muddy airstrip in the jungle would describe how he'd salvaged an R-2800 from a wreck, and it had flown another 100 missions. These stories would be read aloud during shift changes, the words echoing against the high steel rafters. It reminded the exhausted men and women that they weren't just building machines. They were building the margin between a young man's death and his homecoming. The factory was the silent guardian of the sky. By 1944, the R-2800 Double Wasp had become the heartbeat of Allied air power. It didn't just power the Corsair, it became the engine of choice for a legendary stable of aircraft. It was the thunder inside the Grumman Hellcat, the carrier-borne fighter that broke the back of the Japanese Imperial Navy. It was the muscle within the Republic P-47 Thunderbolt, a 7-ton beast of a fighter that could withstand incredible damage and still bring its pilot home. It powered the B-26 Marauder, the A-26 Invader, and the black-clad P-61 Black Widow night fighters. The demand was so relentless that Pratt and Whitney couldn't build them fast enough alone. They recruited the titans of the automotive industry, Ford, Buick, and Chevrolet, to become subcontractors. Master engineers from East Hartford traveled to Detroit to teach assembly line workers, who were used to the looser tolerances of automobiles, how to read micrometers to the 10,000th of an inch. The auto manufacturers proved to be brilliant students. Within months, engines bearing the Ford nameplate were indistinguishable in quality from those built in Connecticut. By the war's end, more than 125,000 R-2800s had been produced. It was one of the largest production runs in history, a river of steel and fire that flowed from the heart of America to every theater of the war. If you saw an American fighter in 1945, there was a nearly 50% chance that its heart had been forged in East Hartford. In August 1945, the sirens finally went silent. Peace arrived with a blinding flash and then a long, heavy exhale. But for Pratt Whitney, victory brought a brutal reckoning. Within weeks of the Japanese surrender, the U.S. government canceled 85% of its contracts. $400 million in business vanished into the ether overnight. The factory that had breathed life for 40,000 workers suddenly required only 6,000. 34,000 people were laid off in a matter of days. Most had known it was coming, but the knowledge didn't soften the blow. East Hartford, which had hummed with the energy of a boomtown, emptied almost as quickly as it had filled. The boarding houses closed their doors. The hotbeds grew cold. The constant vibration that had been the heartbeat of the town for 4 years simply stopped. For those who remained, the silence was disorienting. Entire wings of the factory went dark, the machines covered in heavy tarps like ghost ships. The era of the great piston engines was ending. A new sound was beginning to echo in the distance, the high-pitched whistle of the jet engine. The R-2800 workers, who had mastered the art of the piston and the valve, found their incredible skills becoming obsolete. Some adapted, learning the new language of turbines and thrust-to-weight ratios. Others simply walked away, carrying the weight of the war in their stiff joints and shadowed eyes, trying to forget a factory that had asked for everything they had. Today, the R-2800 double wasps sit in museums, their steel hearts silent behind velvet ropes. One is at the National Air and Space Museum. Another is near Bradley International Airport, just miles from where it was born. Visitors walk past them without truly understanding what they are seeing. They see a machine. They don't see the 40,000 lives that converged to build it. They don't see the woman who inspected 10,000 tappet rollers a day, or the machinist who spent 4 years of his life perfecting a single crankshaft design. The workers are mostly gone now, their names unrecorded in the grand narratives of history. But their work remains. Every time a restored Corsair fires up at an air show and that distinctive guttural rumble fills the air, it is an echo of East Hartford in 1943. That sound is a memorial to a generation that refused to fail. They built more than engines. They built the margin between tyranny and freedom. The Pratt Whitney factory still stands in East Hartford. It builds jet engines now, monsters of titanium and carbon fiber. The technology has changed beyond recognition, but the core philosophy remains: precision, reliability, and the knowledge that a thousandth of an inch can still be the distance between life and death. We tell these stories because the people who lived them deserve to be remembered, not for the glory, but for the work, for the precision, for the silence of a factory floor that once held the fate of the world in its hands.